the third slide, you can see there are three important steps. Okay, first, you need to convert continuous time signal to discrete time signal or digital signal or sequences. Okay, in second step, you need to compute or process of these sequences. Okay, in third step, okay, you need to process the process sequences from the process signal, okay, need to be converted back to continuous time signal. Okay, alright, as introduction, most signal in real life are continuous time signal, for example music, speech, images. Okay, so increasingly discrete time signal processing algorithm used and implemented using discrete time analog or digital system. Okay, so basically the same thing. Okay, your input might be music, speech, my voice, the images. Okay, so basically for you to process the signal, we need to convert it to discrete time signal or digital signal. Okay, after that, what you need to do is, okay, of course you want to listen the music, the speech in the smooth form. So again, after we process, you need to convert it back to continuous time signal. And for you to convert it back to continuous time signal, you need to use a converter. Okay, so we have analog to digital converter to convert from continuous time signal to digital signal, and DAC is digital to analog converter for you to convert from digital to analog for you to convert from digital to analog signal. So it is necessary to determine the relation between the continuous time signal and its discrete time equivalent, okay, both in time domain and frequency domain. So basically for this point, okay, that's why I go back to your notes. Okay, and then okay, if you look at slide number 4, it is actually the definition for analog to digital converter, digital to analog converter. And then we have sample and hold. Why we need sample and hold circuit? Because we want to sample and hold the value for analog to digital converter. Okay, and then we have reconstruction filter. So basically reconstruction filter is actually to smoothing our signal. Anti-aliasing filter. Okay, why we need anti-aliasing filter? Because we want to reduce the bandwidth of continuous time signal to avoid aliasing due to sampling. Okay, so basically for the next slide is actually the general block diagram of digital signal processing. The next slide, continuous to digital signal conversion. Okay, so if you look at this slide, okay, we have XT is your input signal, PT is your impulse train. So basically impulse train is your carrier signal. So what happen? Your carrier signal will carry your signal. Then what you have to do is your input signal will be convolved or multiplied with your impulse train. So you have XPT. Okay, and then we have conversion of impulse train to digital sequences. Okay, this is the example of the graph. Okay, we have impulse train sampling. So again, XT is your input signal, okay, which is in continuous time form. Okay, and then we have our impulse train. So basically, if you look here, ST we are going to multiply with PT. So what happened? It is actually our PT will carry our XT. So then look at the output. Okay, you can see we have our impulse train, and then we have the shape of our input signal. Okay, so if you look at this equation, we have XPT equal to XT multiplied with PT equal to summation SNT delta T minus NT. Okay, so next we have multiplication or modulation property. Okay, so in time domain we multiply our input and, for example, input and H, our impulse response. So when we multiply in frequency domain, what happened? We have to transform from multiplication become convolution. Multiplication become convolution, and from convolution become multiplication. In this case, okay, we multiply. So basically, in frequency domain, we need to convolve. Okay. Okay, why we have 1 over 2 pi here? Because 1 over 2 pi represent the signal must be in periodic time signal. Will be repeated at every 2 pi. So we have 1 over 2 pi. X p j omega equal to 1 over t x j omega minus k omega s. This equation is actually our sampling process equation. So this signal will be sampled at every t. Okay, so why we just have 1 over t? Why we don't have 1 over 2 pi anymore? Because we already multiply our impulse train with our input.